This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
Support for this podcast and the following messages come from our friends at the Paul Mueller Company and Hopsteiner. Please thank them. This podcast wouldn't be possible without their generous support.
Paul Mueller Company has been manufacturing quality brewing equipment since 1964. Our innovative design and engineering will save you time, labor, and ingredients, sending money back to your bottom line. Learn more about our new mobile hop module at paulmueller.com. This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Yeah, basically the concept here is to think about yeast the same way you think about hops and malt, okay?
This week on the show, Active Dry Yeast. We discuss several studies ranging from shelf life to performance versus freshly propagated yeast to applications in bottle conditioning. One great topic with two great guests.
Hi, my name is Marcelo Cerdan. I am the sales director for the Americas for Fermentis Active Dry Yeast.
Hi, my name is Kevin Lane. I'm the technical sales manager of the United States and Canada for Fermentis Yeast.
You put together a poster for the 2017 Master Brewers Conference that was a review of Active Dry Yeast, its shelf life, and consistency. Give listeners the big picture here.
Yes, the idea of this poster was, of course, this poster is the result of a lot of research because we had many questions, a lot of questions from the industry about the shelf life and the stability of the yeast, okay? We know that Active Dry Yeast contain just a little bit of water. This is the main principle why the yeast is stable. But of course, after years and years of experience, accumulating experience within Le Saffre, which is our mother company, we decided to review the consistency of the Active Dry Yeast during the time. Because, of course, the technology changed. We improved the processes. I think it was time to check again and to revalidate our initial concepts of the stability. And, of course, we found that we were able to extend our shelf life from 2 to 3 years. This is the main conclusion of the study.
Okay, let's hear about how Active Dry Yeast is produced.
Okay, Active Dry Yeast... there are similar points to the yeast propagation in the breweries, but of course there are some differences. We start from pure cultures, okay? We check the purity of these strains in the lab, and then we ship slants to different plants across the world. What we do, we have a lab phase, a laboratory phase, where we propagate under sterility, and then we go to the industrial phase, okay? In that industrial phase, what we do is we use a technology we call fed batch technology. Okay, basically what we do is we produce biomass. We inject air, a lot of air, and also we keep the sugar concentrations very low in order to avoid the production of alcohol. So all the sugars we add in that fermentation process are used to produce biomass. And then after we grow the yeast, then we need to go through the drying process. It's not a single step. We have about 3 steps. The first one is a centrifugation where we reach about 18-20% dry matter. And then we have a vacuum drying filter process where we reach about 30-32% dry matter. And then we have what we call the drying process, where we get about 94-96% dry matter. That's the most important part of the process, because of course we need to use heat, but we use a fluid bed technology. In that process, what we do is we add hot air, dry air, and all this energy is used to extract the water from the yeast cells. But during this process, we manage the process in order to avoid the yeast being heated by the air. Okay, so basically, people think that we heat the yeast and that we kill the yeast, but all the energy coming from the air is used just to extract the water.
Something that's interesting to add to that is that each strain is slightly different in the production process. So it's not just one recipe that's applied to all of them in terms of the drying. Rather, it's kind of somewhat unique to each strain because each strain is capable of handling that process in the drying process slightly differently.
Interesting.
And of course, something to add to this comment is that strains are different, and we can see in this study, for example, we can point the differences between lagers and ales.
The use of active dry yeast in breweries only has about a 20-year history. Tell us about that evolution, and you also mentioned that the process has changed a bit too, so talk about that.
Part of the reason for this study was to try to show the consistency over time with what's currently available in the market. So 20 years ago, we didn't have the same technology that we have today, and what we've done, at least what we've tried to show with the study, is that things have come a long way from 20 years ago to today. The use of dry yeast really in today's market allows for breweries, especially craft breweries, to diversify their yeast cultures that they use in the brewery. So with the dry yeast, you don't need a propagation system to be using it. It's directly applicable to fermentation, which allows you to be much more dynamic in the strains that you use.
Yeah, basically the concept here is to think about yeast the same way you think about hops and malt. Okay, for each recipe, you select the active dry yeast or you want to use for the process. That's the novelty we brought for the industry, the most important. And of course, you can detach for difficult practices for the small brewers, like the propagation. So we respect the propagation. I think it's something that it's very important for a lot of breweries. But when you are small, and you have to take care of about a lot of things in the brewery, it's very difficult to handle that process correctly and to avoid issues with contamination, for example, of the quality of the yeast.
There are several independent studies that your poster summarizes. I'd like you to walk us through each one. Let's start with the most recent shelf life study that was presented at the 2017 European Brewing Congress.
Okay, what we show here, first of all, we developed different tests in order to study the shelf life of the yeast. Of course, the first problem we have is that if we need to develop a method just to mimic the aging process, okay, because otherwise we have to wait 3-4 years, okay. It's something that we developed internally inside Le Saffre. Okay, that test allows us to do a forced aging test, which is basically to subject the yeast cultures to high temperatures in some conditions. Okay, so basically what we see 1 month in these conditions mimic the aging in 1 year in normal conditions. Okay, that's the first step. After we set up this methodology, then we decided, okay, we need to validate that technology with the process, with the natural aging process. Okay, it means that in fact we have to compare. We have been accumulating for years different samples, And then we validate, we cross the information in order to be sure that the test was correct. Okay, that was the first step of the study, and then we subjected the different yeast strains. We compared the forced aging testing and the natural aging testing. Of course, we found interesting things. We found that there are some easy strains that are very robust, and some others that are more weak. And as I said before, we found also important differences between ale strains and lager strains.
Do you want to comment on how storage conditions affect shelf life? So, for example, if brewers are storing the active dry yeast either in refrigerated conditions or frozen or at room temperature and so on.
So really the best storage conditions for our active dry yeast is to be refrigerated. And it's ideal. So our yeast can be frozen and it can be stored at ambient temperatures. We don't usually recommend storing the yeast at warmer than ambient temperature, 20 degrees C, 68 degrees Fahrenheit. Because the warmer you go, typically the faster you have a loss of viability and a loss of the fermentative power. But within that range from frozen to ambient temperature, there are differences over time, but they're not immensely different. Some of the graphs do get into that information a little bit, showing that really the most consistent fermentation is when you have the yeast refrigerated for the certain period of time, whether that be 1 year, 2 year, or 3 year.
Coming up.
So it really shows, with the same strain, whether it's freshly propagated or dried yeast, you end up with the same profile of the beer.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. This episode is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
And here's what's coming up on the Master Brewers calendar. The District Michigan Summer Social is July 7th at Fitzgerald Park in Grand Ledge. District Northern California meets at Admiral Maltings in Alameda July 19th. Don't miss the Brewery Safety Webinar July 25th. District St. Paul, Minneapolis joins forces again with the Minnesota Craft Brewers Guild for the 5th Annual Business and Technical Conference July 27th in Duluth. The annual District Texas Summer Meeting is the weekend of August 3rd in Kerrville. The ASBC MBAA Brewing Summit takes place in San Diego this August. Discounted early bird registration closes June 19th. Register at mbaa.com, where you can also view the full calendar of events with more details or find a district meeting near you. Now back to the show. Okay, let's get into some of the other studies, and maybe you can comment more on some of the different performance parameters.
So some of the conditions, some of the parameters that we were measuring and comparing were, number one, the viability of the yeast over time. So how much viable yeast you have over the years versus freshly dried yeast. And then additionally, the fermentative power, which is really the rate of fermentation for the yeast during fermentation, comparing that year to year. And then went as far as to compare the volatile compounds, the esters and the higher alcohols at the end of fermentation, and the amount of time that the fermentation took. So really it's comparing the health of the yeast over the time but also the beer that's resulting from the fermentation, whether or not it matches the beer that was made when the yeast was freshly dried versus 3 years down the road. And really, that's where the consistency comes in, is that you see very similar, if not almost identical, volatile compounds produced during fermentation, and the rate and completion of fermentation following essentially the same line.
Beyond shelf life, brewers are probably most interested in understanding how active dry yeast stacks up to the same strain of freshly propagated yeast. Talk about that.
Okay, well, we have some studies that I think were done by the end of the 90s. Those studies were performed at the BRI in the UK. In fact, in the poster, we showed some results with lager yeasts. And we compared freshly propagated yeast with active dry yeast, and we showed no significant differences in the final product. We have evaluated obviously the different parameters like the esters, floral notes, fruity notes, bitterness, astringency, the body, and all were, we found no significant differences between this comparison. Okay, of course, I think there are a lot of experiences in the brewing industry. Some people say that maybe when during the first generation in the active dry yeast they see some differences. Despite it's not, there's nothing in this study about that. Today we couldn't confirm that there are really significant differences between the first generation of active dry yeast and freshly propagated yeast. Maybe this is something we need to do and to confirm in the future.
And I think something also that's important to note is the research done at the Brewing Research Institute shows, at least the information that we have on here shows the range of these different parameters, the different characteristics of the beer, over 11 brews of freshly propagated yeast, and then one control beer that was produced in the same time frame versus the active dry yeast of the same strain. In this case, it was a lager strain. And really, the interesting thing is with those 11 freshly propagated yeast, the range is fairly narrow in terms of the profile that was detected. And with that, almost every single one of those parameters is within the same range. There is one, I believe, that is outside of the range, but it's really not a significant difference that it could have been, just testing wise. So it really shows, with the same strain, whether it's freshly propagated or dried yeast, you end up with the same profile of the beer.
We used to hear about problems years ago where cells could rupture during rehydration if the instructions weren't followed properly. Is that still a concern today?
Oh, that's a good question. We have recent studies about that. And in fact, because of course, this is one of the most common questions we have from brewers, okay? We did a lot of studies. In fact, after this study we presented last year about different rehydration conditions. Okay, we tested a lot of different conditions, a lot of temperatures. We finally concluded that really the loss of viability is really very, very low. When you follow normal brewing practices, okay? It means that we used to believe in the past that we need high temperatures to rehydrate the yeast, to have a very gentle agitation. And today, we know that this is not true, that you can rehydrate the yeast under different conditions, probably better adapt to the brewing practices. Those studies are very important for us, because now we launched one concept what we call easy to use. Easy to use is something new in this market. It's something that says that you can rehydrate the yeast very safely, and in fact you can add directly to the wort without previous rehydration. We don't see significant differences when we follow all these different practices. This is something we are starting to communicate right now, and there is hard science behind that.
Very cool.
Yeah. So just to add to that a little bit. So the study that we ran was on different media. So whether it be water, distilled water, wort of different concentrations. In addition to that, we did temperature of the water or wort. So we were testing a lot of different parameters to see, is there really a condition that is more beneficial or a condition that you really want to avoid. And it was a communication that we made, like Marcelo said, for years, that you have to rehydrate in water and you have to have a certain period of time at a certain temperature. And that would be in a different tank than your fermenter, which leads to a lot of complications for the brewer. So the information that we've seen recently, the information that we're starting to communicate on, is that those different parameters aren't negatively affecting the yeast in either performance or in the finished beer. So what that allows is for the brewer to add the yeast directly to the fermenter and avoid any possible infection in the water or any complication in handling that rehydration solution outside of the fermenter, and just add it directly to the fermenter and let the fermentation take place.
Your poster also mentioned the use of active dry yeast in bottle conditioning. Do you want to talk about that at all?
Yes, following maybe the Belgians are the more expert in terms of bottle conditioning. What we did some years ago is to find the best strain for bottle conditioning. Basically, what we wanted to do at that time is to find a yeast strain that could perform in extreme conditions. Why extreme conditions? Because you have a lot of alcohol, a lot of toxicity in the beer. So you need a very resistant strain for that. But also something very important, when you do bottle conditioning, one of the things you need to avoid is to change the sugar profile of the primary beer. It means that, for example, if you have a lot of maltodextrose in the primary beer, you want to keep that maltodextrose and without fermenting, because that's part of the beer flavor. And what we tried to find at that moment was a yeast strain that can ferment at different conditions, extreme conditions, but then only fermenting dextrose, which is the sugar basically added to the fermentation. Okay, so avoiding the consumption or assimilation of maltodextrose and just to avoid overcarbonation, for example.
And the other thing to add to that quickly is just that, I've seen in breweries across the US and into Canada, that's because that's where I work, but some breweries will be using the yeast that they use for primary fermentation to apply to bottle conditioning. And the problem that you see with doing that practice, among other things, but one of the majority issues, is that you have yeast that has gone through fermentation. So the yeast has been exposed to alcohol, whether it's low or high, the lowered pH of the beer, which is generally lower than the start of fermentation. And the yeast has worked for a week or 2 weeks. And that yeast at the end of fermentation won't be necessarily as healthy as yeast that you're starting with. So the benefit to brewers adding a second strain that isn't going to affect the carbohydrate profile of the beer, is only going to ferment the simple sugars, is neutral in character, and is really robust, is that you'll have a consistent bottle conditioning over time. you're not throwing any additional variables at the yeast other than the different types of beer. But because of our studies, we found that F2 in specific is able to handle those more challenging environments.
All right. What's the next frontier for Active Dry Yeast at Fermentis? What are you guys working on now? Developing new strains or something different?
Yes, we are always trying to develop new strains. Okay? We say that we have a pipeline full of R&D projects, and the idea is to have 1, 2, or even 3 strains per year. We are working very hard. Of course, the demand of the market is changing. People is asking for more easy strains to diversify the products. We take in consideration those requests in order to launch new R&D projects. It's not easy to launch an easy strain in the market because it requires a lot of R&D work. So not all the easy strains can be dried, and also for some of them you need to find the right protocol. So it takes a lot of time. It's not something that we can do from one day to another.
That was Kevin Lane and Marcelo Cerdan here on the Master Brewers podcast. You can view charts from the studies we talked about by downloading their poster from the 2017 Master Brewers Conference proceedings, available at mbaa.com/store. I'm really looking forward to the ASBC MBAA Brewing Summit coming up this August in San Diego. It only happens every 4 years, and it's not like any other conference you've attended. The Brewing Summit is 100% the science and technology of brewing. No pep rallies or business lectures, and you'll be surrounded by some of the smartest men and women in our industry. If you can only attend one conference in 2018, this should be it. Register now at mbaa.com.
Since there's like one thing that I should have told you, or maybe 2 things that you should have known.